Hello, welcome to this video on the average rate of change and looking at secant lines for polynomials. So we've got f of x equals 10x squared plus 6x. We're asked to find the slope of the secant line from x equal h to x plus h. So this right here is also called the difference quotient. And the difference quotient is f of x plus h minus f of x all over h. Because what we actually see in that denominator is we're going to get x plus h minus x, plugging in just the normal secant line average rate of change formula that is f of b minus f of a over b minus a, where our a here is x and our b is x plus h. Oh, I did that wrong. This should be from x to x plus h. And we'll see in the denominator the positive x and the negative x are going to cancel out. So if we plug in to our function here, our f of x plus h, so I'm just looking at this part right here, is going to be when we plug in x plus h everywhere we see an x in our function. So that's going to be 10 times x plus h squared plus 6 times x plus h. All of that is going to be our f of x plus h minus f of x. Well, f of x is exactly as the problem is given, 10x squared plus 6x. And we see that our denominator is going to simplify to just h. Right, if we multiply and expand all of that, x plus h, quantity squared, remember that we can write those next to each other and FOIL it out, or we can use the formula, but we'll get x squared plus 2xh plus h squared is what we get when we square that. I'm going to go ahead and distribute the 6 on this second term, so we'll get plus 6x plus 6h, and then distribute the negative on the parentheses at the end, so minus 10x squared minus 6x all over h. And we can start combining like terms. We've got a positive 6x and a negative 6x. Let's go ahead and distribute the 10 to this first set of parentheses here. That's going to be 10x squared plus 20xh plus 10h squared. We still have our plus 6x, or plus 6h and negative 10x squared. All of that is still over h. We can finish combining like terms. We've got a positive 10x squared and a negative 10x squared. And what should happen at this step is every term that is left has an h. So we can divide by h on every term, factor out that h and divide it on the bottom. That's going to leave us with 20x plus 10h plus 6. And that is going to be our slope of our secant line. So that's going to be, I'm going to call that m with a little subscript SEC for secant. We're going to find the value of that secant line when x is equal to 1, and then we've got a couple of different values of h here. So we have our slope of our secant line is going to be equal to 20x plus 10h plus 6. We're going to let x equal 1 on all of these, and then we're going to have h values of a couple of different values. So we're going to have h at 0.5, h at 0.1, h at 0.01. Our x value is going to be 1 on all of them. So if we plug that in, we're going to get 20 times 1 plus 10 times 0.5 is going to be 1/2 of 10, which is 5, plus 6. 20 plus 5 plus 6 is 31. And then if we plug in 10 times 0.1 plus 6, that'll be 20 plus 10 times 0.1 is going to be 1. So 21 plus 6 is 27. 20 times 0.1, 20 times 1 plus 10 times 0.01 plus 6. That's going to be 20 plus this middle term is now going to be 0.1 plus 6, so that's 26.1. And if we're not quite sure what that pattern is, we could go one more. We could do 0.001, and we'll get 20 times 1 plus 10 times 0.001 plus 6, and we get 26.01. And what we see is these numbers are going to get closer. The smaller h is, the closer this is going to become to 0. And what we're going to be left with is just the 20 and the 6. And so our slope of our secant line is getting closer to 26. All right, let's find the equation of the secant line at x equals, let's do x equal 1 because that's what we have been doing here. X equal 1 with h equal 0.01. So we just found when x was equal 1 and h is equal to 0.01, we had a slope of 26.1. So we know that our slope is going to be 26.1, and we know x is equal to 1, but in order to find an equation of a line, we have to have both an x and a y. So we're going to find our y value by plugging in x equal 1 back into this original equation way up here at the top. So if we plug in x equal 1, we get 10 times x squared plus 6 times x. So 10 times x squared plus 6 times x gives us a y value of 16. And so y minus 16 equals our m of 26.1 times x minus our x value of 1 gives us a slope of a line 26.1 x minus 26.1, and then if we add 16 to both sides, we get 26.1x minus, that'll be 10.1. Alright, so we can check our work and we can look at what this is telling us as far as the graph is concerned by going to our y equals menu and plugging in that original function, 10x squared plus 6x, and the answer that we got, 26.1x minus 10.1. The window that I've got this set on doesn't have to be this window, but with that 10x squared, it is a pretty skinny parabola. So I have this graphed from x equal -3 to 3 and y equal -10 to 30. And if we look at that graph, we have our parabola, that's our original function, and then we have this line here. And at this angle, you can't really tell what's going on. You can look at your table and see that as you get close to 1, or at least at 1, we get the same y value. But if you get too far off of 1, even 0 to 2, your y values are 10 points off. But we can zoom in on our graph, go to zoom, and I'm just going to zoom box here, and I'll go from x equal 0.44 y equal 0.3, and then we'll just go just to the other side of 1. And then, so I'm going to zoom in pretty much just on that little section of the graph, and we see there's our parabola, and we can see our line gets really, really close. In fact, it just barely touches actually at that 0.1. Here at x equal 0.925, our y values for our two functions, one's 14.05 and one of them's 14.51. And the closer we get to 1, oh, I need to be on trace. So at 0.925, our y value on our original function is 14.1, and on our line is 14.05. And if we get a little bit closer, those numbers get a little bit closer to each other. And the closer we get to 1, the closer those y values are to each other. All right, I'll see you guys next time.